Hello and good afternoon to all of you. I hope all of you are doing well and all of you are in good health. If you can remember and recollect, in the previous class we had discussed some of the important roles and responsibilities that an operating system performs in a computer system. We had identified memory management, process management, file management, IO subsystem management, and other associated operating system services as some of the important roles that operating system performs in a computer system. And if you can also remember, we had discussed file system management, memory management, and process management in detail in the previous class. So, continuing further, in today's class, we will discuss IO subsystem management. Now, attached to a computer system, there may be different types of IO devices that enables user in order to perform purpose-specific business. Now, one of the important responsibilities of operating system is to enable user to use the IO devices without having to worry about the underlying hardware complexities or peculiarities that are associated with the IO devices. So, operating system is responsible for enabling user to communicate with the IO devices in order to perform operation by abstracting the complexities that are involved or associated with the IO devices. Now, some of the important, so as I've said, the operating system is responsible for hiding all the peculiarities of hardware devices or IO devices from the user and should be capable of enabling user to use the IO devices in order to perform purpose-specific operations. Now, IO subsystems are responsible for memory management of IO devices. Now, this is a very important task that is associated with the IO devices, that is memory management, because as we all know that a computer system is a collection of components where the different components operates at different speed. So if you want a central processing unit to interact with the IO device on behalf of the user, now the central processing unit generates or produces data at very high speed, whereas an IO device may not be capable of collecting the data at the same speed. So in order to establish proper coordinated communication, rather coordinated and complete communication between the IO device and the central processing unit, we require a proper memory management technique. So there has to be an efficient memory management technique that is capable of ensuring consistent and complete communication being established between the devices and the IO devices, or between the computer system and the IO devices. So here we will discuss a concept that is called as buffering. So buffering is a mechanism of storing data temporarily while it's being transferred from the computer system to the IO devices. So with every IO device we have associated buffers. So buffers are transient storage that are capable of storing the data while it's being communicated. Now the next one is caching. So we'll not discuss caching in detail because we have already covered this. So caching basically refers to a mechanism of prefetching a set of instructions and data that is frequently used by the processor in order to ensure enhanced throughput, or enhanced performance. So storing part of the data in a faster storage for enhancing the performance. Now next one is spooling. So spooling is a very important concept that one needs to understand. So as I've already said, in a computer system there are devices that operates at different speed. For an example, the rate at which the job is being assigned to a printer by the central processing unit may be relatively faster compared to that of the speed at which the printer is capable of performing the job of printing. So here what we do is we associate a spool with the printer which will arrange in sequence all the jobs that are being assigned to the printer. So as and when a printer completes or executes a particular job, it will look for another job to execute in the spool. So the spool will be populated in sequence, and the job will be taken up by the printer from the spool in sequence. So in order to synchronize communication between the computer system and the IO device or printer, so what we do is we associate a spool. Now the next important IO system responsibility is making the IO devices known to the operating system and of course to the computer system. Now this particular operation is called as porting. So every IO device should be correctly ported to the computer system so that the operating system is capable of interacting with it. So we have two types of ports. We have physical ports and we have logical ports. So logical ports are called as drivers. So drivers are basically programs that are associated with the IO devices that helps the operating system recognize the IO device as one of the ported device. So again I'll repeat it. So device drivers are the programs that are associated with the devices that allows or that makes operating system recognize the IO devices that are attached to the computer system. So these device drivers enable and ensure proper communication between the computer system and the devices, the IO devices. Now the next important IO services that operating system operating system services that operating system performs is creating environment or providing environment. So so an operating system is responsible for providing a consistent environment for the process to execute. Now this is very important. So unless the environment is not created, a process may not be capable of performing its desired behavior. So in order to ensure that a process performs all the desired behavior in order to attain the set of well-defined objectives, the operating system has to provide a suitable environment to it. Now next one is user interface. So it is to be understood that no matter what may be the level of complexity involved or being managed by the operating system, if it does not have a good user interface, the overall usability of the operating system goes down. Again, I'll repeat it. No matter what may be the complexity of the problem that is being solved by the operating system, if the operating system does not have a very usable user interface, the usability of the operating system goes down. So this implies that an operating system should have a very consistent, uniform, stable and user-friendly user interface through which the user will be able to interact with the operating system, or using which the user will be able to interact with the operating system. Now there are different types of user interfaces that an operating system may have. So, for example, an operating system may have a command line interface, or a graphical user interface, or a direct manipulation interface, or a menu based interface, or a touch based interface. So there has to be a good user interface associated with the operating system that enhances the usability of the operating system. Now the next important service that operating system provides is program execution. So it should allow programs to load, run and terminate. Now IO operations. So an operating system should be capable of establishing proper and coordinated communication between the various devices that are there attached to it, or IO devices that are there that are attached to it. Now next one is file system manipulation. So operating systems should be capable of enabling user to perform read, write, create, delete, search, decide on the primitives of the file system and list the file system. So one of the, as I've been saying in the previous classes as well, one of the qualities, one of the fundamental qualities based on which the operating system will be judged is the way how it organizes the file and the file system. Now next one is communication. So operating system should be capable of enabling intra-process communication as well as intra-system communication. So it may be communication within the process or in between the processes, or within a system or in between systems. So an operating system should be capable of facilitating all of this. So in today's class we have learned about IO subsystem management, and we have learned about some of the important services that are expected from the operating system, or that an operating system should provide. Now let us try to create a schematic representation of whatever we have learned in today's class. So to begin with, further there are a few more services that are to be discussed. So error handling and error detection and error handling, this is one of the important responsibility of operating system. So operating system should be capable of identifying all possible errors that may be associated, or that may be associated with the functionalities that are supported by the operating system. So with each and every functionality associated with the software, with the operating system, there may exist various exceptions. So an operating system should be capable of identifying all possible exceptions that may be associated with the operating system functionalities, and then operating system should be capable of deciding on an appropriate mechanism for handling it and recovering from it. So this is very much important. So error detection, so it should be rather error detection and error handling. So error identification, error categorization, and error handling. Now next one is debugging facilities. So operating system should provide debugging facilities. So facilities for identifying the source of error from the point of detection. So there might be several errors that may be encountered while performing operating system services. So when an error is detected, so the error has to be solved. So operating system should facilitate debugging for debugging of errors. Now next important responsibility is resource allocation. So this we have been learning in the past. So operating system is responsible for controlling and coordinating allotment of resources to the various processes that are there in the computer system. So resources includes memory, it includes CPU time, it includes IO devices. So operating system should be capable of coordinating and controlling allotment of resources in between the processes that are executing in a computer system. Now next one is accounting. Accounting is very much important. So operating system should be capable of keeping track of the resource utilization by the various processes that are there in the computer system. So a computer system may have different types of resources. So there has to be a proper accounting done of the resources of the resources that is there in the computer system, and its utilization by the various processes. Then further on, protection and security. So an operating system should be capable of controlling and coordinating the use of all the computational resources, and it should also be capable of ensuring authenticated access to the computer system, so that only the privileged users are capable of utilizing the services of the computer system. So these are some of the notable operating system services that are there. So we have discussed creation of environment, significance of user interface, program execution, then IO operation, then file system management, then inter-process and inter-process communication, as well as inter-system and intra-system communication, then error detection, followed by debugging, resource allocation, accounting, protection, and security. Now let us try to create a schematic representation of whatever we learned in today's class, in order to ensure that it's easy to remember and it's easy to understand. Now, to start with, a computer system has a collection of computer hardware. So using the computer hardware through the operating system, the users are capable of performing operation. So you have computer hardware that is to be utilized in order to perform operation. So in order to make use of the computer hardware, we have operating system. So operating system is a program that acts as an interface between the user and the computer hardware. Now, operating system has in it a set of well-defined operating system services, which includes memory management, file system management, process management, I/O subsystem management, environment management, execution management, communication management, error management, resource management, accounting management, debugging facilities, protection, and security management. So these are the some of the prominent operating system services that are provided by the operating system. Now, a user is supposed to avail the services in order to use the computer hardware for performing certain business. Now, that can be done through a well-defined operating system user interface. So every operating system should have a well-defined user interface that allows the user to avail the various operating system services that makes use of the hardware in order to perform certain purpose-specific business. Now, as I've already said, a user interface should be consistent, complete, uniform, and usable. So you can have either graphical user interface or command line interface or menu based interface or interface that is based on touch, voice, form or natural language. So you can associate any type of user interface with an operating system, but we need to ensure that the user interface is uniform, consistent, complete and usable, because the usability of the system depends on the attractiveness of the user interface. So the user will communicate with the operating system to avail the operating system services through the user interface, making use of the hardware in order to perform business operations. Now, in order to ensure that the user through the user interface is capable of availing the operating system services, we require system call. So system calls are capable of connecting the user interface to the operating system services. So through the system calls, so the user will be able to interact or avail the operating system services. So between the user interfaces and the operating system services, we have the system call. And eventually we have the user and the system initiated program. So whenever a user wants to avail operating system service in order to perform a business operation, it has to interact through the user interface, making use of the system call, using the underlying hardware in order to achieve the desired objective. So this is a very neat schematic representation of the way how the operating system services are to be availed by the user. So in today's class, what we have learned about is we have learned about I/O subsystem management. We have learned about the importance of memory management. We have learned about the importance of buffering. We have learned about the importance of caching. We have learned about importance of spooling. We have learned about importance of device drivers, how it allows to put external I/O devices to the computer system. Then we learned about extended services that are provided by the operating system, wherein we talked about environment, user interface, I/O operations. We talked about program execution. We talked about file system manipulation. We talked about communication. We talked about error handling and error detection and handling. We talked about debugging. We talked about resource allocation, accounting, and eventually protection and security. And then we represented all of this with the help of a very neat schematic representation. So this particular representation is very much important. So thank you very much. We'll call it a day, and we'll meet again in the next class.